Assalamualaikum students and friends. Today's episode clarifies the differences among formula mass, molecular mass, and molar mass. Join me as we explore these key concepts which are prerequisites in understanding problems in stoichiometry. So stick around, watch and learn. So the given question, work out the following. Number one, formula masses of hydrogen nitrate or HNO subscript 3. Next, sodium bicarbonate or NaHCO subscript 3. For number 2, work out the molecular masses of C12H22O11 or sucrose and diesel oil or C12H23. And number 3, work out the molar masses of potassium chlorate KClO subscript 3 and ferric sulfate or Fe subscript 2 quantity SO subscript 4 quantity subscript 3. Before we work out those computations, let us first emphasize the difference between formula mass and molecular mass. Formula mass is used for compounds that are made up of ions and have primarily ionic bonding. Molecular mass is used for compounds that are composed of molecules and have primarily covalent bonding. Now, the term molar mass uh, is either the formula mass or molecular mass of 1 mole of a compound. A mole consists of 6.02 raised to the 23rd power particles. Particles means the number of atoms, molecules, or ions. And this number is called Avogadro's number, denoted by capital N, in honor of the Italian physicist and chemist Amadeo Avogadro. If we are referring to just an element, its molar mass is automatically equal to its atomic mass. But if we are talking about a compound, its molar mass is its molecular mass or formula mass, also expressed in grams. As an example, all right, supposing you're asked to calculate the formula mass of magnesium hydroxide with the formula Mg quantity OH quantity subscript 2. So in this formula, okay, there is one magnesium atom. Each magnesium atom has an atomic mass of 24.3. All right, that is in atomic mass unit, U. Oxygen is inside the parentheses, all right, with the subscript 2. That means we have to multiply 2 by 1. It's understood inside the parentheses that there's only one oxygen atom. But outside the parentheses, we have subscript 2. All right? So we get two oxygen atoms. Each atom has an atomic mass of 16.0 U. So times 2, that's how we got 32.0 U. Likewise, hydrogen is also inside the parentheses with no subscript. But outside the parentheses, of course, you have the subscript 2. So you have to multiply 2 by 1, meaning there are two hydrogen atoms. All right? Each hydrogen atom has an atomic mass of 1.0 U. So times 2 times 1, of course, is 2.0 U. So adding these three, we will get the formula mass of magnesium hydroxide. That is equal to 58.3 U. Alright, we call this formula mass because magnesium hydroxide is an ionic compound. Alright, in addition, when this formula mass is expressed in grams per mole, we also get what we call the molar mass. Alright, so the molar mass of magnesium hydroxide is simply equal to 58.3 grams per mole. Ay, inay ko. So let's now answer the questions in the problem. Question number 1. Calculate the formula masses of hydrogen nitrate and sodium bicarbonate. All right. Let's have the calculation for the formula mass of hydrogen nitrate first. All right. So just like what we did in our earlier example, we determine the number of atoms, okay, for each element. Hydrogen only has one. All right. So its atomic mass therefore is 1.0 U. Likewise, there's only one nitrogen atom. All right. And the atomic mass of nitrogen is 14.0 U. All right. So 14.0 U is the atomic mass of one nitrogen atom, while oxygen has three. All right. And each oxygen atom has an atomic mass of 16.0 U. Multiply that by 3, we get 48.0 U. And if we add these three uh, atomic masses, then we will getting the formula mass of nitric acid, which is equal to 63.0 U. We call it the formula mass of nitric acid or hydrogen nitrate because the compound is an ionic compound. For the next ionic compound, sodium bicarbonate, commonly named baking soda. Okay? So, in this compound, there's only one sodium atom. All right? And the atomic mass of sodium atom is 23.0 U. All right? There's also just one hydrogen atom. So the atomic mass of hydrogen is 1.0 U. And likewise, carbon only there's only one carbon atom and its atomic mass is 12.0 U, right? But there are three oxygen atoms. So the atomic mass of an oxygen atom is 16.0 U. So times 3, we get 48.0 U, all right? And that gives us a total of 84.0 U, which is, of course, the formula mass for uh, the compound sodium bicarbonate, which is also an ionic compound. For question number 2, we are asked to calculate the molecular masses of these compounds. All right? We say molecular masses and not formula masses because these two compounds are what we call covalent compounds. All right? The kind of bond that hold these atoms together is a covalent bond. So the first compound is actually uh, this formula C12H22O11 is actually the chemical formula for sucrose, all right, which is the ordinary table sugar, all right. So in this compound, there are 12 carbon atoms. So multiply that by 12.0 U, we get 144.0 as uh, the total atomic mass of the 12 carbon atoms. There are also 22 hydrogen atoms. All right. Each hydrogen atom, of course, has an atomic mass of 1.0 U. So multiply that by 22, we get 22.0 U as the total mass of the 22 hydrogen atoms. And for oxygen, we have 11. All right. Each oxygen atom, of course, is or has an atomic mass of 16.0 U. Multiply that by 11, we get the total mass of 176.0 U. Okay? So, getting the sum, we get 342.0 U. And we call this the molecular mass of sucrose or table sugar. For the next covalent compound, C12H23, also known as diesel oil. All right? A byproduct of petroleum oil, of course. So, in diesel compound, there are 12 carbon atoms. So, times 12.0 U, we get the atomic mass of the 12 carbon atoms equal to 144.0 U. There are 23 hydrogen atoms. All right? So, the total mass of the 23 hydrogen atoms is 23.0 U. So, adding them together, we get 167.0 U, which is the molecular mass of the compound diesel oil, which is, of course, another covalent compound. All right. For question number 3, we are to calculate for the molar mass, all right, molar mass of uh, the compound. The first compound here is KClO3, also known as potassium chlorate, all right? And the other one, Fe2 quantity SO4 quantity 3, is the chemical formula for ferric sulfate, all right? Or commonly written also as uh, iron quantity number 3, all right? Then sulfate. There are two ways of uh, calling this compound. You can call it ferric sulfate or iron 3 sulfate. So let's have the computation for the molar mass of potassium chlorate first. There is only one potassium, all right, in potassium chlorate. And each potassium atom has an atomic mass of 39.1 U, all right. Likewise, there's also one chlorine atom. And each chlorine atom has a mass of or atomic mass of 35.5 U. But there are 3 oxygen atoms. So 16.0 U times 3, it gives us 48.0 U. So adding them together, we get um, the formula mass of potassium chlorate equal to 122.6 U. We use the term formula mass because potassium chlorate is another example of an ionic compound. But since we are asked for the molar mass of this compound, we simply express the formula mass in grams per mole. All right? So 122.6 grams per mole becomes the molar mass of potassium chlorate. And finally, for the compound ferric sulfate, or also named ferric sulfate or iron Roman numeral 3 sulfate. Okay? So, checking the chemical formula, we see that there are 2 iron atoms. All right? Fe subscript 2. Each iron atom has an atomic mass 55.8 U. So times 2, it gives us 111.6 U, which is the atomic mass of the 2 iron atoms. Inside the parentheses, we have sulfur, all right, with no subscript, but, all right, uh, the whole, what we call ion, we call this SO4 as a polyatomic ion, sulfate. And since sulfur is inside the parentheses with subscript 3, it means that there are 3 sulfur atoms. All right? And each sulfur atom has an atomic mass of 32.1. So, times 3, we get 96.3 U. This is the atomic mass of the 3 sulfur atoms. Now, likewise, oxygen with a subscript 4, all right, is also inside the parentheses with the subscript 3. That means we have to multiply 3 and 4 and get 12. 12 being the number of oxygen atoms in this compound. All right? Since each atomic mass of oxygen is 16.0 U, okay, multiply that by 12, we get 192.0 U. All right? And adding these 3 atomic masses, all right, we get again the formula mass of ferric sulfate equal to 399.9 U. All right, which when expressed in grams per mole, that is 399.9 grams per mole, that becomes the molar mass of ferric sulfate. All right. So that concludes my presentation, all right, for this topic. Till the next episode, mabuhay, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.